Alright, so kind of predictable that we'd have some snake oil caps in here. Well, you know, they're Sozos, they do work, but they cost a mint and they're fucking massive to the point where they're almost useless. Like some of these leads have had to be bent over even to fit a fender, like eyelet board layout. They're just ridiculously large for the value and they cost a mint. I'm 99.9% confident there was nothing wrong with either the blue Pactrons that would have come in this, because I've never seen one fail, or those brown chiclet things. I've never seen one of them fail ever. So often they just replace everything when actually the leaking board is to blame rather than leaking caps. But I don't like this across the board changing film caps. It's pretty much never required other than some special cases like the yellow Astrons in the Tweed, early Tweed stuff, which all pretty much all fail, or the mustards, which like to crack at the ends and allow moisture ingress. But yeah, changing everything, another red flag. Shotgunning, I think, is what a lot of people call it. Find what's causing the leakage, fix that. Look, I get it with electrolytics because they all have a shelf life and they have a rated hour life of usage, and anything above that is a blessing. But if you want the thing to be reliable, you kind of need to preemptively change them out. Like if you're touring with the amp, you don't want it to shit the bed on stage. Film caps, that's not the case. They pretty much work indefinitely unless they get damaged or they're just shitty quality. So there's a bit of spaghetti in these ones to begin with. It looks like a bit of that's been cleaned up. It looks like some excess wire's been relieved off the thing. You still got like, we're getting into it. As I'm looking at it, my brain's going off, making little checklist mental notes of everything. So I think we'll just have to start from one end. Let's start from the power end and work our way back. Okay, again up here, just everywhere I look, there's just strange things. So right, so you got your mains going over here with a large heat shrink. You've got a dual pole, dual throw switch. You got the active going to the fuse tip, the fuse ring to the switch, so that's good. Got a dual pole, dual throw switch. The active and neutral both being switched by that, so that's good. That's kind of the ideal way of doing it. All this wire can be cleaned up quite a bit though. I don't like having the primary touching the valve socket basically. Everything's pretty messy and could be routed a lot better. Sort of half decent soldering. Everything's stiff as shit in solid core though, which I'm not a fan of because it invites cracking. You got to mix the solid core and stranded. Everything feels like Teflon, however, which again is good, but I'm not a fan of the solid core stuff. I've got a screen grid resistor which is rubbing on the chassis screw, so that's not good. That's the case on both of them. And just take a little bit of downward pressure and you'd have your screen grid shorting out to the chassis there. As we suspected, these two sockets are for bias measurement on the cathode. They've got a 1 ohm cathode resistor. Looks like a 3 watt per valve socket. Looks like you've either got the original or a replaced carbon comp grid stoppers there. So up at the power supply, that switch on the bottom, I thought it might have been a solid state or a valve rectifier switch, but what it actually is doing is switching between two separate windings on the transformer. So I'll check the data sheet on the transformer. You probably got two different HT taps there to suit various models, and you just cap off the one you don't want. In this case, you can switch between the HT, and all the HT throughout the amp will vary as a result. So the bias will be either ideal for one and way off for the other, or not ideal for either, and a compromise between the two once you set the bias. Okay, this doesn't make any sense at all. You've got two 7 watt 47 ohm resistors. Like a 47 ohm heater balance resistor will dissipate about 0.2 of a watt in normal conditions. So putting a 7 watt there just makes sure that if something does occur, heater to HT short somewhere, then these won't blow and you'll blow your power transformer instead. So yeah, I use half watt fusible metal film resistors, and I use 100 ohm. So you're dropping about half that, so about 0.1 of a watt or something. But if something goes wrong, they fuse straight away without even seeing any burns or anything, whereas this would cause all sorts of damage. So we'll replace them with some... This is if we go ahead, we'll replace them with some more suitable power range resistors. But looking closely here, champions, you see what I'm saying? Do you see what I see? Solder blob. We've got another blind solderer. The solder blob's pretty much touching the bracket there, which is grounded to the chassis, so that would be shorting out one of the heater taps to ground anyway. So yeah, you'd have... if it is touching, and it looks like it is, you'd have one side grounded and your heater balance would be way off. And the soldering's just really terrible Muriel. So I'll have to redo all that. Got the universal taps there tapped off, hopefully wired to 240 volt. But I don't trust anything in this amp anymore with what we've seen. So it looks like they've changed, well, it doesn't look like, they have changed the master volume to a post-phase inverter master volume. There with a dual gang pot. I'll check the values and stuff in that and just see. I mean, we can leave that in. I'm not a huge fan of post-phase inverter master volumes anyway, particularly in Fenders. The stock master volume in this is great as long as you just remove the bright cap across it. It's very usable then. Everyone either disables it entirely. Disable the push-pull, fair enough. That's a horrible function in these things anyway. Sounds terrible. But yeah, the original master volume in these really comes to life once you just remove the bright cap across it. That's one of the mods I do to these as standard. I've got another cap hiding under here. It's silicon to the side of the chassis. Relatively securely, but I don't trust silicon on a cap casing, especially the metal. What the hell is that going to? So it's a 47 microfarad 550 volt. And it is connected to the screen node. So he's paralleled another cap, probably because the ripple was emitting quite a bit of hum because of the paltry 23 microfarad of reservoir capacitance. Oh my god, champions. Alright, so down here you can see the original board from what was solid state rectified. You'd have your 2 diodes and then some more in series. So four diodes in a full wave rectifier with a grounded center tap, but all that's been removed because it's all been changed to a valve rectified. And we've got a what looks like a Vishay 470 ohm bias input resistor there. It looks like the original diode. I like to replace them just to be 100% certain your bias is solid. But looking at the bias circuit, we've got all sorts of other weird shit going on. But let's not get ahead of ourselves. So the HT comes off the pin 8. That's correct. Runs over to the standby switch. Then we've got a change of wire color code, blue. And then we've got 2 nodes coming off of that. So we've got a 2.7K. Another big no-no for other techs is put the fucking values facing upwards, would you, champion? But I can see that's worn off, so I can't even tell what it is. So I'd have to measure it, assuming that it's within spec. Again, it looks like just parts bin thrown in, whatever they had lying around. Probably value whatever was lying around too. So you've got a dropper resistor coming off the standby before the choke. It goes off to the choke, then it comes from the choke to the screen grid. Okay, so the screen grid is its own tree, basically, its own node. There's no dropping from there. The rest of the preamp is sourced from this 2.7K, which pulls off the HT from the B+. And then that goes off to your various droppers. Your phase inverter node there. Okay, that's weird. On the stock amp, you had your 2.7K, so I'd say that's standard. That fed the phase inverter node, and then all the other nodes fed off the end of that. So this is an addition here, this one here, separating the screen node up from the rest of them. Don't know if that was requested or if that had any, you know, grand scheme behind it. But all right, so the customers report that this has been black-faced. It's not true either. All the phase inverter values are as per the original ultralinear silver face amp. Even the input coupling cap. So what they did is they divided all the values in the phase inverter by 3, but then they multiplied the cap by 10 off the black face values, I mean. So instead of replacing all the values in this area to the original, you know, 1 meg grid leaks and the 22K tail resistor, you can leave all of them in, but just change the cap value to about 3.3 nanofarad, and then you've got the same sort of frequency response of the phase inverter that the black face output stage had. So again, that's another nice, quick, easy little silver face mod that you can do to really get a bit more of that more traditional tone. And I believe that, combined with the master volume and the bright cap across it, is part of the reason these amps get a bad rap, rather than the ultra-linear nature of the output stage itself. Right, so working our way across, we've got more replaced film caps. Looks like we might have a replaced roach there. The original might have been failed, that's fine. We'll check all these carbon comps for drift. But the main reason this amp was brought in is because the customer was concerned that the wax on the board was leaking. So we'll check all of that as well. If that is the case, this will be a full strip and rebuild, and if we're going to do that, we may as well strip the whole friggin' thing and start it from scratch. But we're talking like $2,000 for that kind of job, because it's very time consuming. basically building a new amp in a shell. It takes you all that time to strip everything down and all the time to build it back up again. You'd actually be better off probably building a new amp from a kit in terms of labor anyway. Alright, so we've got new bypass caps. Got a mixture of Nichicon VX series and Vishay caps, which are my go-to, so that's good. The VX series from Nichicon are obsolete now, so these are probably like 10-year-old already. There is a date code, but they're facing the other way. At least they put the values facing up on these ones. You can see down here on the Sozos, like, you can't even fit them in a fender. Like, if you can't fit a film cap between like 1.5 inches, it's just ridiculously large. So of course everything's floating way up above the board and just waiting for the leads to be fractured. All the soldering's really sketchy too, just piggyback blobs on the top of the eyelet, which probably aren't sticking very well. There's a couple of replaced plate loads there in carbon comp. They look like maybe even 2 watters. They're massive. Just a bit of a mixed match of parts. So got a really long strange one there, and then a really fat oversized one there. Alright, so we've got a critical area up here. For some reason they've put the bias. I don't like having rear accessible bias controls at all. The balance is bad enough on the stock amp, but they've put an overall bias control accessible from the rear. However, look at this resistor. It's pretty well touching the casing of that pot, and that would kill your bias supply completely and throw your output stage into massive runaway. And it looks like there's a gel. There's like a greasy gel filled in this pot, like to the brim. Like someone's packed it full of grease. Gross. And you might also notice that the level of this, those terminals are pretty much touching the top of the cabinet, which has the shielding on it, which is grounded. And again, that could kill your bias supply. I can't believe I've got to say this, but if you put like a straight edge on the edge of the chassis, it's about 1 mil to those leads. So if anything was disturbed, it would touch the shielding. And you can see the tech who implemented it was concerned as well, because they put a bit of duct tape in the area to try and insulate the shield, but it would just bite straight through that. And it's not even in the right spot anyway. The contacts are back here where we would miss the tape. So the shielding on these things often tells a bit of a history. So here you can see it's something pretty horrible's happened here. Some vaporizing's occurred, and that's the hum balance pot, which love to go open circuit or fail if there is a heater to high tension or high voltage to heater fault. That pot goes up in flames. Sometimes they do anyway, they just short out or they go open circuit. So that flameage there would have been from that humdinger pot, which is another word for it. Over here we've got another shit stain, and that's located above one of the output valves. So that's probably a shorted valve causing the screen grid resistor to go open circuit and flame up in the process. Down here you can see where one of the wires, or some of the wires from the primary, were rubbing against it as well. It's good to tie stuff off so it doesn't rub against particularly the primary, rub against anything. If it was near that staple, it could have shorted through the insulation. It's all stuff you got to be aware of. And writing stuff on the chassis I'll never understand. Like on, like that's the power switch, to remind the tech that that's the power switch. Like you really need reminding yourself that that's the power switch. So all those nondescript jacks on the back were actually speaker outputs. Looks like we've got a 2, a 4 and an 8 ohm tap there. And then pulled the feedback from the 4 ohm tap. I believe on the stock amp it was pulled from the 8 ohm tap. And they've also got one of those switches down there, just turns off the negative feedback entirely. It just cuts it off. So that's one of the switches. All these heater wires melted. And again, you got about 1 millimeter between that heater line and the screw there, waiting to short out the heater to the chassis, to ground. They were just put in to tame oscillations that were the result of careless layout as they started cutting costs on assembly and just getting unskilled labor to do it. But if you carefully lay stuff out, you can get rid of them and open her up a bit in the top end. Okay, so here's some strangeness. We've got a floating bypass cap there with a 2.2k resistor under it. That's a 100 microfarad cap. That's going off to this switch here, and that switch, terrible soldering. Looks like they've burnt the fuck out of the switch contacts too. There's a closer look, just everything's melted and burnt, like they've dumped so much heat into that switch that it's probably damaged the switch too. If you're melting the wiring jacket back by a ½ inch, you're going to be hurting the switch as well. So what they've done with this switch is, despite the wiring, they've made it switch between two cathode biasing and bypass values on V1A. So it's switching between the standard 1.5K 22 microfarad and 100 microfarad 2.2K. So that changes your cutoff frequency from like 4 hertz to like 2 hertz. So completely useless. All it will do is just add a pop every time you change the switch. So I think they thought adding more capacitance would just magically add gain. That's not the case. It changes like the cutoff frequency, and the 2.2K is negligible compared to the 1.5K. Rob Robinette's got a lot of good articles on that kind of thing. But yeah, I've got no idea what I guess that was probably the goal with this one, but I doubt it would do much other than just add a pop every time you change the switch. Oh, so much to take in, champions. Have to check all the values, see what other stuff's been changed. Everything else looks more or less stock values, just replacement parts, which probably didn't need replacing. So what I might do is just gently fire this thing up and just see, well, just check the bias and everything's stable, and see what the original complaint is. There's complaints of noise, crackling and stuff. So we'll see if we can narrow that down, at least determine what is causing that, and if they just want to solve that one problem, we may be able to do that and leave everything else as is. Otherwise, I think we're going to be talking a full rebuild for this one. Alright, so just checking out the 6L6s on the tester. They're reasonably stable now. They've been up for a few minutes, and no catastrophic shorts or anything, so that's promising. Alright, so just measuring the resistance across the output transformer, primary, blah blah blah. We'll just see how this thing goes, what the voltages are, what the crackling is, and just I've removed the possible short circuit down there in the heater supply. We're just going to give it a little bit of juice and wait until the rectifier comes up and just see what happens. Wish me luck. Alright, champions, moment of truth. We're drawing about 20 watts from the wall. Got the master volume wide open. Starting to get some signal conducting on the output stage. Crackling. Just going to unplug the input. A lot of noise. Check some voltages before we carry on. Alright, so I reckon that because that noise is so consistent, I think we might have a bad valve. But what I've done is put a 1 meg resistor between the two probes, so basically from this probe to ground, so it's not floating, to measure for leakage. We've got about 10 millivolts on the treble cap there. Got about 1 volt on the treble cap there, where we should have nothing. Just probing into the board at various points. Yeah, we do have a lot of board leakage. So I'd say this would be a strip and redo. That puts a big red cross next to this job. What I will do is just pull some valves and see if we can get that crackling and sort of background noise to stop. Take the cock rings off. Alright, so pulling V1, no difference. Pulling V2, the hiss stops. So I'd say it's leakage from the board and around the front end there. So you could probably clean just those sections, maybe float that ceramic off the board there, and that would probably achieve it for a cheap cost. But you're going to have other effects elsewhere in the amp, so she's not going to be singing until you get to the root of the problem, which is that wax starting to conduct, unfortunately. So what I'll just do is lift this ceramic. We'll just tack solder that temporarily. So now we've isolated that connection from the board entirely. We'll do the same thing on the vibe channel. This cap's already been replaced, so I dare say they were chasing their tail, trying to fix leakage there, and it just wouldn't go away no matter what, because it was the actual board doing it, and probably weren't aware of that being a problem. Alright, so we'll just fire that up and see if we've got rid of that, or at least the majority of that noise. This will be like a big onion, so there'll be a whole bunch of noise and crackling and distortion sources all working together to make a pretty ordinary sounding amp. So solving one of them will usually just reveal the next one. Alright, so that's gotten rid of most of it. Still a bit of crackling there on the pot. So there could be some DC present there still from the other caps in the tone stack that are further away from that plate load resistor high voltage end. So this pretty much confirms the fact we're going to have to do major work to this job. So I think it's going to be a matter of we redo vast areas of this amp, or we don't touch it at all. I could sort of do just for the bench fee what I've already done and just float those components up off the board, secure them a bit better, and give it back to him, or we could go the whole hog. So I'll give him the option for both. I'll just ask him what his budget is before I go crazy writing up a quote, because that would probably take an hour in itself. Alright, so a demonstration of that cathode switch. Yep, as expected. Does a big pop every time you flick it. It's at the back of the amp though, so it's not like you're going to be doing that while you're playing, but let's see what the difference in sound is. Got a lot of hum from this thing. Now we've got rid of that crackling and basically hissing. Got some microphonics happening there as well. No discernible difference as expected. I mean, we just ran the math, you know, like you can see straight up it's not going to do anything. So there you go. Confirmed. Alright, so even though we've got rid of the initial crackling at all levels, as we turn it up, there's a lot of noise, a lot of crackling, scratchy pots, hum, hiss, crackling. So there's a lot of work to do to this amp to get it sounding good. Let's see if the trem works. We've got popping in the trem, which isn't good. So the trem's just popping, but it's not modulating. So no trem. So that's like what I'm counting like 8 problems in terms of its performance. Let's see if the reverb works. That sounds lovely, doesn't it? Alright, so looks like the trem started modulating again. I think we might have a bad ground somewhere, because yeah, it's intermittently operating. Alright, no reverb either. Just get more noise as you turn it up. So no return at all. Awesome. So is there anything on this amp that does work? Not really. Let's check the bias on the output stage and what that different high voltage switch does. Alright, so we had some funny behavior there when I gave it the full voltage. So we've got about 2 volts drop across about 60 ohms per side. It's at about 425 volts on the plates. So that's about 50%, a bit under 50%, 14 watts per side. So about 50%, 47%. So if you go to the lower voltage range, that takes us down to, say about, oh, go halfway between the two, about, that works out to about 4 watts per side. Or about 15% bias, so that'd sound fucking terrible. If you're going to drop your voltage, you've got to massively increase your bias, well, decrease your bias supply voltage closer to 0, I mean. It's always difficult when you're talking about negative voltages. Otherwise, you're going to be biased so cold that crossover distortion's just going to be through the roof. There's very few amps that have done this well. I've seen a few that have done it well. Ironically, the DSL40C, despite its other issues from Marshall, is a pretty good way of doing it. It basically does a similar thing to this, but it compensates the bias. So the valve's still running at a pretty optimal range despite the lower HT being supplied to the plates and the screens. Whereas this is just a brute force, just drop the voltage through the floor and the bias voltage remains the same because it's coming from a different tap. So a pretty useless switch, and it's going to sound pretty terrible in a low voltage position, so why even have it? So all I can really do with this one is just tell the customer everything, show him this video, and just see what he wants to do, because I don't think there's a hell of a lot we can work with here other than, well, I mean, even the board itself has got various conductivity issues, so I think it might be a big fat NO to this one, champions. But anyway, if you see it again, it'll be the Works burger. So hopefully they go ahead with that, because otherwise it's a waste of two nice creamback Celestians. So if you don't see any more of this amp, we've just done that basically. Or if you see the next episode, will be another case of the Silverface Works burger, champions. So until then, thanks for joining us, and join up if you haven't, so you see all the secret squirrel material and all my little secrets, and the vlog as well. Otherwise, I'll see you on the next public video. Take it, squeezy legends, and if you can't be good, just bloody be good at it. Better than this bloke anyway.